Welcome back, boys and girls. So once again we are solving the same exam paper which we started earlier, and we discussed so far question 1, 2 and 3. So today we are going to solve and discuss question 4 of the same paper, and again we are proceeding directly towards question 4 and see what it is. So here this is the question 4, and in this part it says that in industry ethanol is made by reacting ethene with steam. So this type of the reaction is what electrophilic addition reaction. Okay, and he says that use the bond energy values in the given table to find and to calculate the enthalpy change of reaction 1. So no need to be confused with this. Whenever you have a reversible reaction, we are meant to calculate for the forward reaction. So the ethene and the steam, or the water you can say, both act as a reactant in reaction 1, whereas the ethanol is the product. So let we calculate. First of all, remember what is the formula. What is the formula of the what we can say enthalpy change to calculate in this part? Let me write the formula for you. Here I'm selecting the part so that I can solve and write for you. Here the formula is enthalpy change. If you are going to say reaction 1, okay, if not, no problem, just write enthalpy change. How you can say sum of the energies of reactants and then minus sum of the energies of products. So here I'm writing the reactants. In the reactant we have ethene, which makes this type of the bonds. Remember, your grip on the displayed formula is must. If you know how to draw the displayed formula of the molecules, both organic and inorganic, then this will help you a lot. Okay, if you are unable, then it will be what we can say troublemaker for you. Whereas the ethanol, which is the only product of this reaction, we can draw like this. Okay, this will help us to find out, to calculate how many total bonds we have and what are their different types. Like now these are the reactants and these two makes the products. In the product side we have carbon to hydrogen bond 1, carbon to hydrogen bond 2, so I can write 1, 2, 3, 4. So we have 4 carbon to hydrogen bonds, plus we have carbon to carbon double bond, which is 1. So 1 time the carbon to carbon double bond. Then we have this steam or water in which one oxygen atom is bonded to 2 hydrogen atoms. So what we can say, there are 2 bonds, plus there are 2 bonds of oxygen which is bonded with hydrogen, or you can say hydrogen bonded with oxygen, it doesn't matter. Now to the product side we have carbon to hydrogen bond, this is 1, 2, 3, 4 and 5. So there are 5 times carbon to hydrogen bonds, plus we have carbon to carbon single bond, which is 1 time carbon to carbon single bond, plus we have carbon to oxygen 1 single bond, carbon to oxygen, and finally we have oxygen to hydrogen single bond, which is 1 as well. Now the time to replace, substitute the values, and in this case what I'm going to say, just using the values from the table. So carbon hydrogen bond is 3, where is carbon to hydrogen bond is 410, so this is 410, and again carbon to hydrogen, so 410. Now carbon to carbon double bond, which is here, so it's 610, its value is 610. Then oxygen to hydrogen bond, which is here oxygen to hydrogen bond is 460, so it's 460, and also we have here, so 460. Now carbon to carbon single bond is 350, and then carbon to oxygen bond is 360, So there are some extra bonds as well, no need to use them, just use whatever the type of the bonds you have. Now use the calculator. Let me find my okay, and then calculate. Let me calculate for you. For the first one we have 4 times 410 plus we have 610 plus we have 2 times the 460. So the finally for the reactants I'm getting the value of 3170 minus, now the products, let me calculate the products. This is 5 times 410 plus 350 plus 360 then plus 460. So the answer is 3220. As we clearly know that the energy released is higher, so the final answer should be in minus what it should be. So the answer is 50. The answer I got is 50, but it is in minus. Unit for this is kilojoule per mole. I hope you understand how to calculate this. Use the same main formula, use the enthalpy change values from the table, and you can easily find the answers. Understand? Okay, proceeding. Now the next part, here he says that reaction 1 reaches equilibrium at constant temperature and pressure. Deduce what effect increasing the pressure will have on the amount of ethanol. We remember, according to the Le-Chatelier principle, the pressure always shifts the equilibrium from more number of moles to the less number of moles. So in the equation what we have above here, you can easily see we have 2 moles of the gases on the left side, we have only 1 mole of the gas on the right side. So higher moles on the left, lesser moles on the left. So what will happen, increasing the pressure shift the equilibrium from this left side from reactants to the product, and this will definitely increase the amount of ethanol. So the effect we are going to write in a straight way that the amount of ethanol will increase at equilibrium, the amount of ethanol will increase. So let me write. So amount of ethanol increase. Now what's the reason behind? As I discussed, higher pressure shift equilibrium from higher moles, you may write in bracket reactants, to lesser moles or to lower moles, which is product, and that will result in formation of products. So this will result in formation of more amount of ethanol. So this question is done now. Next part, he says that the mechanism for the reaction 1 can be described. As I clearly mentioned earlier, This type of reaction is electrophilic addition reaction. So what's the demand? Let we see what is the demand, then we can act. So the first part, he says, describe the behavior of H3PO4. Remember, this is an acid. This is here typically, actually it is a catalyst, but here the demand says that according to the mechanism shown, that this part is what releasing its this hydrogen, and we know that when something is releasing its hydrogen, which is called as a proton, then it will be an acid. So what I can say that here the phosphoric acid is behaving like an acid, and the explanation for this is, we can say, because it is donating proton. It is proton donor. Then identify the species that behave as an electrophile in step 2. So remember, everything which is electron deficient has a charge of plus. It could be an electrophile. So here we can easily predict this species, this one, okay, this part, this is what, this one, this is electrophile. Second step, the same part is being repeated, so no need to write again, and then this one. So there are two parts, this one and that one, these both are the electrophile. So you have to write exactly what they are written there, or you may write not the semi-displayed, the structural form in the answer for 1 mark. So you have to write both. Understood? Next part, he says that complete figure 4.2 show the mechanism for step 3 of reaction 1. Include charges, dipole, lone pairs. So this is important, so let me draw for you how to show all these things. First of all, remember, oxygen being highly electronegative, it has an extra lone pair of electron. Whereas here, so what is going to happen because of this electron deficiency? So this oxygen atom is going to attack on this hydrogen, and then the oxygen will take away its electron back. When it's take away its electron back, what happens? This bond is broken down, and this part is taking back its hydrogen, a proton. So that's why we can say at the end this part is recovered. Because of the recovery or reproduction, we can say it is acting as a catalyst. So this could be the next reaction, next question. Okay, so keep that in mind. So the mechanism 2 marks, 1 mark for showing the lone pair of electron. The second mark is the complete curly arrow towards hydrogen, and 1 complete curly arrow from the center of the bond towards the oxygen. Okay, so this will give you 2 marks. And furthermore, remember how we can say the phosphoric acid is a catalyst, because it is regenerated, reproduced, or regained, whatever the words you can use. Let me proceed and we see what is going to happen. He said, describe how catalysts affect the reaction. Simplest answer, we can say by decreasing the activation energy. First of all, describe how catalysts affect, we can say it speed up the chemical reaction. How? By providing an alternative route and decreasing the activation energy. Or I'm going to write here. Here we have to write by, first of all, speed up the reaction. Speed up the reaction. And how? Providing alternative route and lower down the activation energy. Remember, activation energy not directly decreased, it is decreased due to the provision of an alternative route. So keep that in mind. Next he says, use figure 4.1 and 4.2 to justify the phosphoric acid is described as a catalyst. As I told you, as it is regenerated at the end, or you may use that regained, reformed, whatever the word you can say, giving the message that it is reobtained and remains unchanged during the chemical reaction, or recovered, whatever the word you can use. Next part, he says that propene also react with steam. A mixture of organic product is produced. Explain why propane 2-ol is produced in the higher yield, because it is a major product. But because he is trying to find the explanation or demanding the explanation, what we are going to write? First of all, just write that more stable carbocation is involved due to the formation of more stable carbocation, due to involvement of more stable carbocation okay, and furthermore you have to why it is more stable, because of two alkyl groups or group attached to carbon with positive charge. With positive charge. Let me explain how. If I just extend this for you. Okay, let's see what is the product propane 2-ol. Let me draw this: one carbon, second carbon, third carbon, and the second carbon we have OH. Okay, so here we have H, 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 H. So what is the definition of the secondary alcohol? The definition of the secondary alcohol is that the OH attached to the carbon, and that carbon is further bonded to one hydrogen and two alkyl or two carbon containing species. Okay, if I remove just this, so this carbon atom becomes what? A cation, carbocation, which is a secondary carbocation. So due to the attachment of this alkyl group and this alkyl group, and they are imposing more inductive effect on this carbon with a positive charge, that is why this is more stable as compared to the primary carbocation. So this is the reason why the propane 2-ol will be the major product and will be in higher yield. I hope you understand. Next part, he says, describe the covalent bonds present between carbon atoms in ethene. Okay, let me again draw this and then we can proceed with the direct answer what to write. Okay, just keep it in mind. What is ethene? Ethene is actually carbon atom that is making the overlapping of two sp2 hybridized orbitals, sp2 hybridized, and one of this carbon atom. So what is happening? These are sp2 hybridized orbitals, but each carbon atom has one unhybridized p orbital as well. 2p orbital is unhybridized with each of the carbon. So this is called as this one, the green one. These are making by overlapping from the sideway and producing a pi bond. So I can write the pi bond is formed by the overlap of 2p orbital with another 2p orbital. And the sigma bonds, this one is sigma bond. So 1, 2, 3, here, and 1, 2, so 2, 3, 4, 5. These are the sigma bonds. How they are formed? We can say by the sp2 hybridized orbital, which is overlapping with another sp2 hybridized orbital. These are overlapping head to head, or you can write direct. Whatever you can write, both are acceptable, head to head, or you may write direct overlap. Okay, whereas this 2p orbital is overlapping the other 2p orbital from the sideway, like you can see from this situation. So what we can say, sideway overlap, and you may write as the lateral overlap. So I hope you understand with the help of this diagram, and you understand the rest of the part of the question. If you have any query, you may ask, no need to hesitate, and inshallah we will solve the next question in our next video. See you soon. Take care. Bye bye.